Hello all, this is Manoj Kumar from ADS department. In this video, we are going to see about the implementation of MLP, which is Multilayer Perceptron, for a non-linearly separable data. First of all, MLP is a type of feed-forward artificial neural network, and it consists of three main types of layers, which is input layer, hidden layer, and output layer. Each neuron in the network applies a weighted sum of its inputs, adds a bias, and passes the result through an activation function like sigmoid, relu, or tanh. Now let's move on to the implementation of the MLP. As we can see, here we are importing the required libraries which are used in this program, and the for the input parameters are taken here, where X is the 2 cross 4 array representing the input feature of the XOR problem, and Y is the 1 cross 4 array representing the corresponding labels for the XOR problem. And here n underscore x is the number of input features, that is 2 in this case, and n underscore y is the number of output features, output neurons, and n underscore h is the number of hidden neurons, and m is the number of training examples, that is 4 in this case, which can be derived from the extort shape of 1, and lr is the learning rate for the gradient descent, and np.random seed is used to get the random number generator for the reproducibility. And in this part, W1 is initialized with random weights for the hidden layer of 2 cross 2 matrix, and W2 is initialized with random weights for the output layer of 1 cross 2 matrix, and an empty list is created to store the loss values at each iteration. Now in sigmoid function, the sigmoid function computes the sigmoid activation for the given input of z, and it returns the value of z. In the forward propagation, we define a function of forward underscore prop. The function performs the forward propagation through the network, and z1 is the linear combination of input and weights for the hidden layer, and a1 is the activation of the hidden layer after applying the sigmoid function, and z2 is the linear combination of hidden layer function activations and weights for the output layer, and a2 is the activation of the output layer after applying the sigmoid function. At last, the function returns the values of z1, a1, z2, and a2. Now the backward propagation. In backward propagation, the function performs the propagation through the gradients. Here dz2 is the gradient of the loss with respect to z2, and dw2 is the gradient of the loss with respect to w2, and dz1 is the gradient of the loss with respect to z1, and dw1 is the gradient of the loss with respect to w1. This function also returns the values of dz2, dw1, dw2, and dz1. Now the iteration is run for about 10,000 times, and here the iteration goes like and here in the iteration we are doing the first step forward propagation for the z1 a1 and z2 a2 values, and in the next the loss is calculated by using the formula which we have defined here, and the loss is also calculated, After calculating the loss, the backward propagation is implemented for the values of dA2, dW2, dZ1 and dW1, and after that the weights are updated in this values W1 and W2. After calculating this, we are going to plot the value of the losses, and the X part is the epochs of which the iteration is occurs, and the Y part consists of the loss values. Now we predict the now the predict function is used to take the three value arguments, which is W1, W2 and input. The W1 and W2 are the weight matrices for the hidden layer and the output layer respectively. Now the function forward propagation is called, but to return the values of Z1, A1 and Z2 and A2, but we only needed the A2, that is the final output of the network. After that we are going to squeeze the value of A2 to remove any single dimensional array entries from the shape of A2. This ensures that A2 is a scalar value rather than any one element array. Now we are going to thresholding to get the binary output. If A2 is greater than or equal to 0.5, the output is set to 1. Otherwise, it is set to 0. This is a common thresholding step for binary classification. And at last, we are going to print the output. This line prints the output, prints the input data and the predicted output data. The I of 0 for I in input converts the column vector input into a list of its elements for easier reading, and we are going to test the predict function. For that, the test cases is given. A list of test cases is created here. Each test case is a 2x1 numpy array representing the different input combinations for the XOR problem. Now we are going to predict for each test case. This loop iterates over each test case in the list. For each test case, the predict function is called with the current weights of the W1 and W2, and the input and the results are printed. As we can see at last, if the input is 1 cross 0, the output is printed as 1, and if the input is 1 comma 1, the output is 0, and the input is 0 comma 1, the output is 1, and if the input is 0 comma 0, the output is 0. So here is the XOR problem output for the MLP implementation of non-linearly separable data. Now let's see some of the applications of the MLP and where are all the places the MLP is implemented here. The first one is the classification. In image recognition, the MLPs can be used to classify the images into different categories, such as identifying objects, faces, or any handwritten digits. Second one is the regression problem. In regression, for financial forecasting, the MLP is used to predict stock prices, currency, exchange rates, or any other financial metrics. Third one is the time series prediction. In time series, for the sales forecasting, the MLP is implemented to predict the future sales based on historical data to help in inventory management and marketing strategies. Next one, in anomaly detection, for the identification of unusual patterns in transaction data that might indicate fraudulent activities. And next, as we all know, the NLP, natural language process, the MLP is used for the sentimental analysis and for the language translation, as well as in chatbots and virtual assistants. And there are also some medical applications of MLP where it can able to diagnose the disease from the medical reports which are all given, like x-rays or MRIs, or by seeing the results of the patient, and it can able to predict the patient health outcomes based on the historical data which is given, and also in the drug discovery for predicting the efficiency of new drug compounds. At last, it is also used in the gaming and simulations field to develop any intelligent agents that can learn and adapt to various gaming scenarios, and simulations using MLPs in simulations to model complex systems and predict outcomes under different conditions. So these are all the various applications of MLPs, and thank you all.